So for the final question, this is just a fraction addition problem, right? This is not an equation. I'm not saying that this equals something else. So I'm not using fraction busters here because it's not an equation. I'm not trying to solve for x or y. I'm just trying to combine these two things. And maybe, perhaps, if we look at what's happening with the numerical example, maybe you can track that with this algebraic problem. So let's say that I had 3 fifths, and I wanted to add to that 5 sixths. So what I've done is I've just picked a value for x and y, and they're different, and I'm just asking you to add these fractions. Well, in order for me to combine these fractions, I need to have common denominators, right? And I can see that this denominator needs a factor of 6 in it, right? Because over here I see that this one has a 6, so this one needs a 6. So what I do is I multiply this fraction by 6 over 6. And that's perfectly legal because what am I multiplying by? Just the number 1. So I'm not changing the value of that particular fraction. The other fraction, if I look at it closely, this one, it needs a factor of 5 in it. You can see this one has a 5. This one needs the 5. How am I going to introduce that? I'm going to multiply this fraction by 5 over 5. Okay, as you look at this now, they now have common denominators, right? Both of them have denominators of 30, or 6 times 5, right? So I can write it as 6 times 5, which is just 30. I can write it as 30 also. And then my numerators, if you look at it, I've got 6 times 3, which is 18. I could write it as 18. I'm just going to leave it as 6 times 3. And then plus 5 times 5, which is 25, right? So I can take this numerical example a step further, and I can write it as 18 plus 25, all divided by 30. And I can combine the 18 and 25 and get 30, I think 43 over 30. If I'm wrong, I'm sad. Um, I don't think I'm wrong, although arithmetic is not often my friend. So no, it is 43. So 43/30. Um, so how can I mirror that with this algebraic problem? Well, I'm going to follow the exact same pattern, right? This fraction, this denominator needs a factor of y. So I'm going to multiply it by a y over y. This denominator, right, needs a factor of x. So I'm going to multiply this fraction by x over x. So if I look at it now, right, my numerators are 3y plus 5x, and they share a common denominator of x times y, right? It's either yx or xy, but because of the commutative property, I know that those have the exact same value. So I can write it as xy or yx. But that's the answer. Now, 3y and 5x can't be combined. They're not like terms, so I just have to leave it here. But this is my solution, right? This is the sum of these two fractions written in simplest terms. So again, 3y plus 5x over xy. And throughout this chapter, there were probably at least 3 or 4 different homework sets where they were asking you to do this with numbers. And the reason is we need to look at and understand these patterns so that we can deal with algebraic situations. So that is our answer for number 13.